Happy Memorial Day, everybody. Make sure you thank a military member today that you get the privilege and joy of studying calculus here in America. Okay, you have one type of problem that's new that's also going to be on your test. It's an extension to the chain rule. It's, yes, a double chain rule. I said double, not two chains. So here we go. F of x. And this is going to deal mostly with trig. So we're still working with trig derivatives. So let's say we have the sine squared of 5x. And I want to find the derivative of that. What I want you to do, anytime you're working with trig and you have your trig expression is squared or cubed, or you have your trig expression to some exponent, I want you to rewrite what that means, because it's easier to see that you have to do the chain rule. So you're ready to do your derivative? Exponent comes forward, and keep everything what's inside the same. Reduce 1 from your exponent, that leaves you with 1. So sine of the 5x at first. Chain rule says since you have something in parentheses, since it's not just a regular x squared, since you have a chunk of stuff, you have to do the derivative of what's inside. The derivative of sine is cosine, and the angle always stays the same. You can never change the angle. But you probably noticed by now that your angle is different. It's not just a plain old x. You have 5x for the angle. That's the new part we're talking about. That's the double chain we're talking about. Is now what you have to do is you have to deal with that angle. Since it is not just a simple x, you have to now take the derivative of that angle, which is 5. So it's an extra little step to your chain rule. Whenever the angle of your trig function is anything other than just x, you have to take the derivative of it. Okay, so now all I have left is clean up. I've got the 2 and the 5. I'm going to multiply together to make 10. And then I have sine 5x cosine of 5x. And that's my answer. Let's do another one that's a little bit sassier, I guess. All right, so let's go crazy with this one, all right? We're going to combine a lot of different things. 1 over square root of x minus, let's say, tangent squared of pi x plus 1. That's my angle. Hi, puppy. Go away. Let's see, do I want to make this any chunkier? Yes, I do. Plus cosine cubed of x squared. That's sassy. All right, this is a chunk of change. You ready? Let me go ahead and scoot this up so we can have room to get this started. Okay, first thing is we got some rewriting to do. Number 1, the first expression right here, you're going to rewrite that. It's x to the 1/2 power because you have a radical, and because it's in the denominator, it's x to the negative 1/2. So that's the first term rewritten. Then we have a trig expression. The angle is right here, pi times x. Remember, pi is just a coefficient. It's just a number like anything else. So pi x plus 1, that's my angle, and that whole thing is being squared according to the problem. Plus, I have cosine. The angle this time is x squared, and that whole thing is being cubed. All right, I know that this squared belongs to the angle and not the cosine expression, because this is the exponent that tells you what's going on with the trig expression. So that's how I know that little x squared is the angle. You really should put parentheses around it, to be honest. All right, here we go. Let's get going. Derivative, bring the exponent forward. I get negative 1/2 x. When you subtract 1/2, negative 1/2 minus another 1/2 gives you negative 1. So that's the first expression. Okay, now I have chain rule here. Bring that 2 forward. So I have minus my 2 times tangent. Don't ever touch the angle. When you subtract 1 from the exponent, you get 1. So it's just this tangent of that angle to the first. But my angle's chunky. Oh, well, not only that, but I have, this is chain rule, right? So I have, this is not just a regular x. I got a whole chunk of thing. Chain rule says times the derivative of what's inside. The derivative of tangent, so you got to look at your definitions. Hopefully you're not still looking at them. You've got them memorized. Derivative of tangent is secant squared, and you always keep the same angle. Oops, I put my 2 too soon. Secant squared, same angle, pi x plus 1. Okay, that's the derivative of tangent. Tangent of whatever angle equals secant squared of whatever angle. The derivative of it, I mean. Now times the derivative of the angle. Pi x plus 1. Pi is just a number. So think of it, if I had 3x, you would tell me the derivative is 3. Well, if I had pi x, the derivative is pi. Oh, I ran out of room. Okay, all of that I just did, all this, that's just the derivative of the tangent expression. Now I have to do the derivative of this cosine. So I bring, and it's got a plus in between those two, so there's my plus. Bring that 3 forward. I got 3 times cosine of x squared. Don't touch the angle. Subtract 1 from the exponent, and I have 2. So there's still 2 of those left. The derivative of what's inside? The derivative of cosine is negative sine, same angle. You never change the angle. That's my derivative of cosine. The derivative of cosine of some angle equals negative sine of the same angle. So that's the derivative of what's inside. Now you have to do the derivative of the angle because the angle is chunky. The derivative of x squared is 2x. Holy monkeys, right? Okay, clean up. There's nothing I could do with that first term except I'm going to go ahead and put, because I have x to the negative 1 power, so I'm going to put that x underneath the fraction part at this point. And it's got a 2 down there. So negative 1 over 2x, that's the first term. Second term, what can I do? So I've got some 2 and a pi that's kind of loose, so those are going to combine and give me 2 pi. And then the tangent and the secant can just squeeze together. Since the tangent is just to the first, I'm just going to write that as the first one in there. Okay. Times your secant squared. So, do I have any parentheses around that? No. Secant squared, and then same angle. Okay, what do we have going on here? The last term, I have a 3 times a negative times a 2x. Combine all those and you get negative 6x. Oops, I already put my negative down there. I was ready. Hold on, I'm going to erase that because I don't want that there. Negative 6x times, let's see, we have this cosine expression is still being squared, so I'm going to put the sine first. So we have negative 6x times the sine of x squared. The angle is x squared. And then we have times, so, I got to squish it in there, cosine. And we are, what's that exponent? We're squaring it. So cosine squared of x squared. At this point, there's nothing you can do. They don't have any common terms you can take out. I'm looking at this tangent expression and that secant expression. I'm trying to see if I can simplify those because tangent is sine over cosine. Secant squared would be 1 over cosine squared, but nothing cancels there. And if I combine those, I have sine over cosine cubed. But that's not a definition of anything. That doesn't simplify anything. So nothing I can do there. So it looks like this whole chunk of munk is your derivative. Okay, so remember the new stuff. If you have anything involved with your angle at all, so a regular trig problem would just be like cosine cubed of x. That's a regular trig problem that you use chain rule. So you would do, that's cosine of x cubed. You would bring the exponent forward, subtract 1 from the exponent, times the derivative of what's inside. My angle is just x, nothing else to do. So it would be that. I would probably rearrange it. A double chain. Oh, whoops. Whoops. A double chain rule. A double chain rule would look like this. Cosine cubed of 7x. Okay, now your angle is a little bit chunkier. And that would look very similar. Cosine of 7x cubed is my rewrite. Bring the 3 forward. Don't change what's inside. Take 1 away from the exponent, that would now be squared, times the derivative of what's inside. Derivative of cosine is negative sine. Don't change the angle. Now, because your angle is something other than x, because you have a 7x, the derivative is 7. And you would end up with 3 times negative times 7. You would end up, well, actually, I would bring this negative forward, by the way, on that one. Negative 21 sine of 7x times cosine squared of 7x. So you got regular problem where your angle is normal and you only have the derivative of what's inside to worry about at the end. You have double chain rule where your angle has something else with it. And when you do the derivative of what's inside, you have one other step of the derivative of the angle. So you're going to have 2 little parentheses trailing there. So that's the new stuff.